Hey there, friends. Jeff Fritz here, and welcome to episode 2 of this series talking about a code project we're working on my live stream called CodeMedic. There's links to the project just below. It's open source. You can download and take a look at all the code that we've been writing up to this point. Now, last time we got things started and identified the project and got the ball rolling. In today's episode, we went through and did a little bit of cleanup from the work that we started in our first episode. This project is designed to help make .NET developers more productive in analyzing and working with their projects at the command line. And we're using some tools like Spectre Console to make sure that we deliver a really nice looking experience that works on Windows, Mac, and Linux. So we did some cleanup on our reports a little bit. We fixed some of the features that were already there and weren't quite reporting the values we wanted. For example, when it would report back the version of the C# language that was being used in projects, it would just say default. Well, now we've updated it so that it returns and reports the exact version number of the programming language that we're using. Additionally, we put some other fixes in there to start adding and exposing capabilities for things like counting the number of lines of code in a project. So now we'll get a report along with our list of projects, the number of lines of code in each project. Additionally, we updated the way that packages were being analyzed so that we could now start to deliver transitive dependencies and report on those packages that our immediate package references depend on. So, right, that's a second layer of packages, and then even third, fourth, and fifth, however many layers deep your package hierarchy goes. So, we've got a couple of those really neat features built, and we even added a little bit of support at the end so that you can run CodeMedic from Docker. No need to install any .NET tools. You can run it directly from Docker. And that's going to open up capabilities for us to be able to run CodeMedic from continuous integration locations. So let me take a look at the code and show you some of the interesting bits that we've added as part of this work that we did in episode 2 here in December 2025. All right, so here's the list of commits that we put in here. And you can see I was very descriptive in the titles of the bug fixes and things that we introduced here. We even got a fix at the end here from Copilot that would take care of the NuGet inspector class that we introduced and add some unit tests and make sure that those tests work on Mac and Linux. So let me head over to the code and show you a little bit more of what these fixes are, some of the code structure that we have, and dig in a little bit deeper on the details. Now, in a console application, we typically start with a program CS file. And yeah, that's an okay place to get started, but we hand things off immediately into this root command handler, our top level command handler, and we'll process arguments from there. Inside of here, this is where CodeMedic is going to analyze the arguments that were passed in and decide exactly what to do. And at this point, it's pretty hard-coded on just the health feature that we've got built, reporting the version that we're using, and even a little bit of help text. Not bad, okay place to start, but clearly as we expand on this, this is going to get a little unwieldy, how it goes through and analyzes this. Additionally, check out here, we allow folks to specify the renderer for the output from CodeMedic. By default, we're just going to format and output things in the console, but we've also got a markdown renderer that's going to deliver the same report in markdown format so that you can attach that to your continuous integration process. You can format that and present that to somebody so they get that clear, human readable output that they can work with and analyze and do a little bit more work with. Now, our health operation actually runs this health command over here. And you see our health command is past that renderer. Is it going to be working with the console or Markdown, and then it proceeds from there, analyzing all the content inside of some target path. So that location where our code repository is, we're working on. Now, down here, you'll see it starts putting together the dashboard by doing a scan and then generating a report based on the results of that scan. That report then is passed into our renderer and it's delivered to the end user. The scan that takes place here, we broke up into several pieces in today's episode. We wanted to go through and first ensure that we restore the packages for NuGet so that you can be sure you see the entire transitive package hierarchy for your projects in your solution. Additionally, we go through and we're refreshing references to the central package repository. If you're using that directory.build.props file, right? We're going to report back, here's the appropriate packages that are being referenced, and they're centralized and how you can use them across the various projects. We're parsing projects here, and if there's any errors, handle and report them appropriately. Now, we format and generate reports using a generic report structure. This way, while this health reporting is a simple, easy way to structure and build a report for health, general health of the project, when we add in other features later, we'll be able to generate reports using the same generic report object, format and deliver that on the console, on Markdown, and even in JSON format in the future. So you see there's some paragraphs and some key values that we're reporting at this point. Nothing too deep, nothing, that we're really calculating a lot about. We're barely scratching the surface of some static analysis of our project. The number of lines of code, the number of NuGet packages, the number of projects that have nullable analysis enabled or implicit usings working, documentation that's being generated automatically from our projects. And then we added a section today that will check to see if there are mismatches in package versions being referenced between various projects in the solution. This is pretty good because it'll give us that report and show us, hey, you can consolidate these references and ensure that your project doesn't have any gaps when things are being restored and features that are misbehaving when they collaborate with each other. Additionally, we broke out the NuGet features so that it's in a separate class here, so that everything that works with the packages is in one place. This gives us isolation for us to be able to inspect, report, and do a little bit more in-depth analysis with our packages in one place. You'll notice we abstracted the file system reference here in the constructor for our NuGet inspector. We wanted to do that so that we could unit test some of the work that's going on here in this class. And we created not just a physical file system implementation of that, but we created a unit test that mocks and provides a unique fake version of the file system so that we can test and generate exactly the results for interacting the file system that we need. We don't have to set things up on disk and move them around all the time. We can just fake them out because we're working with streams and a class that can return the objects that we need to emulate different experiences with our NuGet inspector. Finally, you'll see that we have our tests all running properly. I'll run them again over here in Visual Studio Code for us. Right now, there are 17 tests that are a part of the project, and you'll see in just a second, there's the build, and in less than a second, we're assured that they all pass. You can take a look at the documentation in the repository that'll tell you more about what these tests are, what they're validating, and learn more about our testing process. You'll see that we're using a standard given, when, then syntax for our tests. This is a great structure for us to set up a range our configuration for the tests, act on those tests. When this action occurs, then inspect and take a look at what has occurred, or assert that things have functioned the way that we want. Given when then is very similar to that AAA approach: arrange, act, and assert. So you see that we've got that same type of interaction here as we interact with and build these tests. So that's where we are at the end of day 2, episode 2, working on CodeMedic. I hope you check out the GitHub repository and look to learn a little bit more about the project that we've started here on my live stream called CodeMedic. It's going to be a lot of fun to build this out, and I hope you follow along in our playlist right here on YouTube. So make sure you subscribe, click that bell so that you can be notified when more of these episodes are released on our CodeMedic playlist. Thanks so much for watching.